Skywatcher started out in 1999 in China. David Shen uh, opened his factory, and this was his first brand, the Skywatcher. Does very well throughout Europe. Didn't really get a lot of traction in the US, didn't get a lot of marketing, which is why I was brought on in 2012. The product was not known, it wasn't advertised, so people's perception of the product was based almost exclusively on its price point, which is actually one of its features. It's a really good product for a decent value. So my job was to let people know, make them aware of the fact that Skywatcher products are in fact quality products at a value price. In the US specifically, we have been targeting mid to upper range astronomers, people that are a little more knowledgeable, maybe astrophotographers. We have specifically not focused on the lower end products, acromats or mass market tubes that you would find in department stores, that kind of thing. Ours are more specialty, simply because one, we don't have the manpower to handle the kind of volumes that the lower end stuff would require, and it's allowing us to really hone in on the message and to the people that would appreciate the message of quality and value. Well, the first bit of advice I give people is to be patient. There's a learning curve, and it is, it's science. It's science, but it's amazing science. It's science that you can experience visually and tactily right there in front of you. But it also is going to take time to become proficient at it. So enjoy. Don't be afraid to play around, and again, just be patient. One of the things that we do consciously is interact with the factory on a daily basis with feedback on new products or even existing products. We have a couple of people who are very hands-on, very active out in the field using these products. So when it comes time to modify the products, when it comes time to upgrade the products, we have very valuable real-world experience with them so that we can operate as a partnership with the factory and with product development. So what we found over the last few years is that the photography market and the astronomy market has a great deal of overlap. And by pushing photography products that do astronomy, we are able to introduce a whole segment of the population to astrophotography and astronomy that might otherwise not be exposed to it. We are the party animal of the astronomy community. We try not to do it in the office, but when we are out at star parties, that's definitely true. As far as what age range we're shooting for, astronomy just as a hobby generally skews towards 40 plus individuals, 40 plus years of age and older, but we're finding that with the photography products, our star trackers, our other photography products, those are actually bringing in much younger people in their 20s. It is terribly important that we get these people in, otherwise the hobby dies, and we don't want that to happen. Some of the things that we've been doing is photography first, astronomy second types of products. We're also developing a lot of our products with Wi-Fi capabilities so that you can manipulate them through your phone with a smart app. So I think anything where somebody gets to use their phone is going to skew a little bit younger.
Okay, guys and girls, we're starting a little bit early because Jupiter is setting down pretty quick over in the Philippines. We were going to begin at 2, but we're just jumping ahead by about 30 minutes. Thank you for everybody for coming over to watch the live stream with Christopher Go. Christopher Go, say hello.
Hi there. Sorry, it's still a bit dark here, and I'm on my PJs. We're here imaging Jupiter. The sky is clear. Seeing, unfortunately, is only 7/10, so it's not perfect. What we're used to. Jupiter is still quite low in the sky, around 40 degrees. So the reason why we're starting early is because sunrise is going to happen in probably an hour. So this would be the best time to image Jupiter before sunrise, and sunrise would basically sometimes do bad things on the seeing. So right now we're in the middle of doing an RGB capture of Jupiter. Uh, since we're going to do derotation, I'm right now on the fourth set of my six set imaging. Right now we're with a blue filter. After we do the six sets, I will show you a little bit on how to set up fire capture. Um, Especially when you're using a filter wheel. One thing nice about fire capture is that it automatically scrolls through the RGB. Uh, Here we go. Uh, it's This is the filter wheel that's basically doing all the work for me. Changing the filters, starting the exposure. Everything is automated with fire capture. So here we go. We're doing the R. Earlier, after setting up, we actually used the green to focus on the image. If you look at the image right now, the red is actually pretty good. Uh, we're coming up to the green right now. The quality is, I would say, so-so. Uh, Basically, what we're having right now is we have winds from the north. In my case here, in my location here in Cebu City, the best seeing comes from winds from the northeast, east, southeast, and south. This is the area where I get laminar flow or water from wind from the water or wind from the sea. So that's when you get good seeing. Right now, we're having some winds coursing through the mountains. That's why it's a little unstable, but overall, it's not that bad. You can still see a lot of features. This is the blue filter. You can see the great red spot on the lower right. It's on the right side. The great red spot is about to set, and you can see, the north equatorial belt and the south equatorial belt uh, clearly, even with the blue filter. Okay, we're almost going through with our last run with the RGB. You can
So
see
what
on the right,
so what time is it in the Philippines for you right now?
it's around 4:30 in the morning. It's 4:30 Philippine time.
So is the mornings the best time to do imaging in general for planets, or when it
Right
just gets
now,
dark?
actually, right now, Jupiter is still on the eastern horizon. It's still coming up. We're just starting the Jupiter season right now. So basically, right now we're chasing the sunrise. Jupiter is still not on the, it's not at its highest yet. Uh, it's still rising during sunrise. So basically, right now we're just starting Jupiter season right now. That's why we're imaging basically close to sunrise.
Gotcha.
Okay, so
Sorry, my
we're going
cat's
with the
decided to
green right
join
now.
us.
Hey, no problem. Okay, so what I normally do is I get a set of RGBs, then I take a set of IRs, then a set of methane band. Right now, because of the seeing, I normally don't do UV because UV is quite sensitive to seeing. Okay, we're almost done. You can see because this is my setting for the gain and exposure time. Each filter have different setting, but for Jupiter I normally keep the exposure time the same and just vary on the gain. uh, Sometimes when a haze would pass by, I would have to modify on the, adjust on the gain, uh, or if a cloud passes by. So this is the green. This is where I usually focus. I have a motorized focuser here. This is the what I used. I use a Moonlight focuser, Crayford focuser, and this is what I use for focusing. So this is it's easy to have this hand controller to focus. So what I normally look at is I look at the south equatorial belt, the belt of Jupiter, and just check where I get the sharpest. And I can see some fine details here. Uh, so more or less we get the focus now. I'll go through all my imaging sets. We're going through IR. Normally at this time of the year, I use 5 sets of IR. Then we're going to go through the methane band. Methane band takes about 12 minutes to capture. Okay, here we go. Is there anybody online yet?
There's about 34 people, 35 just went up.
Okay, if they have any questions, they can ask them now.
Oh yeah. So if you guys have questions, feel free to type away. I don't know if some of you are still watching the NEAF live event. Unfortunately, they did have a bit of a hiccup, so they were kind of running over time a little bit. And then we were also pressed for time because obviously Chris doesn't have a infinite night time over there. So what time's sun up?
It's about 5:30, so yeah.
So we'll push it to the very end.
Yes, we'll push it to the very end. And if we have time, we're going to capture Mars.
I think we can.
So we're almost done. Yeah. After we do the methane ban, I think that'll be around 2 p.m. your time. We can do the hardware run on how I set up the. Okay, here we go.
So they're asking, what size of telescope are you using today?
I'm using my trusty C14. I'm using a Celestron C14.
And what mount are you using?
I'm using an Astrophysics AP900 mount.
Oh, okay,
GTO.
so serious mount then.
Yeah, you need, I've been using this mount since 2003 and it has never failed me. So this is quite a durable mount. Many people ask me, yeah.
Oh, Martin is asking, are you using the auto guide feature on SharpCap to keep Jupiter in the center of, in the field of view?
No, I'm using fire capture now. Normally, I would do that early in the evening, but early in the morning, no, because it takes some time to set it up. And especially when you're chasing sunrise, you really don't have time. I just do everything manually with my hand controller here, and it works well. So we're done with the IR. We'll proceed with the methane ban. Now, using the methane ban is going to be, there you have it. We use 2x2 binning. The exposure time is rather long for methane ban. So I'm using this feature with fire capture. This is basically auto capture. So this is going to take about 12 minutes to capture. So I'm using 2-minute sets of methane ban.
Oh, so you're running quite a sequence there.
Yeah. I use this only for methane ban because this version of fire capture that I'm using has a quirk where if you change the gain, the whole thing fails, the auto run fails. So it won't capture on the second sequence. So for RGB, I do things manually because, you never know that a cloud would pass by or haze pass by. And you have to adjust the gain. You'll notice one thing here in this image, you see a bright spot here on the left side, a small bright spot. This is oval BA. So you have 2 spots, the great red spot and oval BA on the field of view. You'll notice that in the methane band, these anticyclones are very bright. This is because the methane band captures high altitude cloud. And one thing interesting this year is that the equatorial zone is very bright in methane band this year. And you can also see the south polar cap also bright in methane band, or the
So one of the
polar hood.
questions here is,
Mm.
you're on fire capture, capturing an AVI. Is there any advantage over SER files?
Well, it's really on preference. I prefer AVI over SER. I think probably because I can play it with any video player. Uh, but if you're doing 16-bit, you will have to use SER. And I always use SER when I'm imaging solar or lunar. That's when I use 16-bit. But for planets, it's not necessary. You can just use 8-bit, and well, it's up to you. If you prefer SER or AVI, there's no processing. It doesn't really matter.
Next question is, fire capture has the ability to control lots of the accessories. Is the focuser controlled there as well? Because I don't see them on the screen.
No, no. Unfortunately, the focuser I have doesn't have a automatic. I'm using a cheap Moonlight focuser with a servo control. So, well, probably in the future I'll get the upgrade this, but it's too expensive for me right now.
I mean, the Moonlight focusers are actually really good focusers to use, and even with the hand controller, it's actually quite useful in that capacity. I mean, you've got other options that you could always use. You can always use the Isato one from Prima Luce Labs or their Sesta
Mm,
Senso. Uh,
mm,
Personally, I like to use Starlight Instruments focusers, especially with their handy stepper motor. And then, of course, Optec
mm.
has their version of the handy stepper motor.
Yeah, yeah. But I think for this one, I really need because the steeper motor has the feedback, and for this to be worth it, the only reason why you want to have an autofocuser or the computer controlled focuser is so that you can refocus in blue and go back to because when you're focusing, the red and green more or less have the same focus, but it's the blue that's always the problem, that's slightly out of focus. So it'll be handy, but overall for image quality, as long as you have a good red and green, you can get a perfect image with just red and green. So we're doing the methane band right now. This is an 889 nanometer filter with I think 16 nanometer band pass or something like that. I'm using a chroma methane band right now.
So, speaking of filters, somebody wants to know if the actual filters you are using are actually genuinely made out of glass.
Yeah, it is, of course. These are chroma filters, chroma RGB and IR filters. The only filter that I have, the UV, is from Astrodon. It is a U Venus filter from Astrodon. But the rest of the filters that I have, I use chroma.
Cool.
So we're almost halfway through the methane ban. It's funny because this might not look like the best image, but scientifically, this is the image that has a lot of things that you will see that will be of scientific value, especially if there's an impact on Jupiter or an impact remnant. These features will be very bright on methane band. So anything, if there's an outburst on Jupiter where a basically an outbreak would occur either in the north equatorial belt or in the south equatorial belt or anywhere in Jupiter, a high altitude plume, this will show up on methane band.
Oh,
So
wow. Okay. Yeah, I didn't know that.
yeah. So even though this doesn't really look as nice as a color image, scientifically this has a lot of value. Uh, but it takes time to get a good image. Uh, this one I really need 6 sets to have a decent image, so the final capture will be won't be grainy. And if you notice, we're using very high gain right now. It's 465, and we're using probably one sixth of a second, one seventh of a second exposure time.
So, just out of interest, you have 6 runs going on compared to what you would do with RGB. Why are you doing 6 runs on this particular set?
Just to get the good signal to noise ratio. Actually, with the RGB, I also did 6 runs. If you notice, you can see all my data over here.
Oh, okay.
So you can see 1, 2, 3, 4, 5, 6 RGB sets. I do 5 IR sets and 6 methane band. One thing interesting about methane band, after we do this, we're going to do a dark capture. So it's easy for me because I have a flip mirror. So all I have to do is to close the flip mirror and capture the dark frames. So in a while, I'll show you how to capture dark frames. One thing about dark frames, you cannot capture single frame because you get too much noise, and the dark subtraction isn't gonna look good. So what you actually do is you capture 5 frames, and this is what we're gonna do uh, in probably a little over 4 minutes. So any other questions, guys?
So another question here would be, from what you were saying yesterday about the binning, explain to people, why are you doing binning on just methane?
Because methane is very faint. You'll have very slow exposure time if you're not binning on methane. It's the only way to capture a decent image, and because of long exposure and uh, methane band is a narrow band filter. It's like using the narrow band filters for deep sky. So the light that goes into the chip is very low. You really need binning to get anything decent. Anyway, I will turn off binning so you'll see what Jupiter looks like without binning. I don't think you'll see anything without binning.
So on average, how many frames should you capture per channel?
Well, it really depends on seeing your telescope, your focal ratio, the gain you use. You'll have to figure out that. What I would suggest is first get about 6 to 7 captures, then start derotating 3, 4, 5, 6, and just look at which goes best. Different telescope, different cameras, different sky conditions have different settings. In my case, with my setup, if seeing is good, I will only do 4 RGBs. Right now, since seeing is so, average, I would do 6. If seeing was about 5 or 6 out of 10, I would go as high as 15 sets.
I don't know if you've actually used this yet, but Celestron actually has a motorized focuser for their SCT. Have you actually used one before yet?
Well, is it a Crayford focuser? Because the thing is, I would prefer a Crayford because if you're using, once you change, you move the mirror, especially at this magnification or focal length that we're imaging. This planet would be out of the field of view. So
Oh,
you need
so
a fine focuser. You need a Crayford focuser.
right. So for those of you who are watching this and want to understand a little bit more about this, so Martin was talking about the SCT focuser that goes onto the actual knob that controls the mirror. Now, ideally, you should probably use a Crayford focuser on the back of the SCT and then lock the mirror down to avoid any kind of image shift. I mean, even though the newer versions of the C11 and so forth have the upgraded mirror and focus locks, there is still a slight bit of shift as you tweak the actual fine focus, which can end up making the whole thing go out of the field of view,
Oh, there's
especially with a
another thing.
C14.
Actually, there's another thing. We actually use the mirror lock. because if we don't mirror lock, there's what you call the focus creep. So that's the reason. Another reason why you're gonna use the Crayford focuser, because when you're mirror lock, there's really no way you can focus. You can only focus one way
Right.
because of the lock.
Somebody's asking, do you have a social media account? So, do you have an Instagram, Facebook,
Oh yeah,
and all
I
that
do.
stuff?
I
That was
have a
almost
Facebook
obvious.
account.
Do you want to tell everybody what it is?
Okay. Christopher, go.
So there
Okay,
you
here we
go.
go. We're done with the methane ban. We're gonna turn this off. I'm gonna close the flip mirror. Here you go. It's closed. It's dark. So look at here. Limit 5 frames. So I normally take 2 captures of the dark frames, and the reason is because before when I used one, sometimes the dark frame didn't come out very well. So you can see the dark, the dark hot spots, hot pixels. So the dark frame will take care of that. Okay, we'll open back and we'll go back to RGB before we go to Mars.
Well, do
I
you want to
hope the
just show
seeing is
what it
better
looks
now.
like? Do you want to show what it looks like without the 2x binning real quick?
Oh, okay. Here.
Oh,
This is how Jupiter looks like without the 2x binning. So you don't really see anything. Okay, we're back to green. Okay, let's see. We may have to refocus again. Seeing's getting a little better now. See, I'm actually refocusing on the green right now. You can see the oval BA over here and another spot over here. Oh, that looks perfect. I'm now focusing on this dark spot over here to see when we get the best contrast. Okay, we'll do another 6 runs over here. It's almost yeah, okay. It's almost 5 a.m. So it'll take about 9 minutes to do the 6 runs. Then we're gonna move to Jupiter. It's actually almost sunrise right now. It's already twilight. You can see the sky is getting brighter. Simon, can you turn on the webcam of the other laptop?
sure. Let's see if we can get it working.
Not this one, the other one.
Oh, sorry. How did we lose this? Two seconds.
So you notice that everything based on histogram. Here you can see it's about 90+%. So this is how I change my gain to make sure it's about between 90, as long as it's below 100%. It's still dark. Well, it's still dark. Let's see. You can see it's almost twilight.
All right, they should see. Oh yeah, that I can see it now.
Yeah.
Hopefully nobody saw my
It's
Zoom
slowly,
GoToMeeting ID number and password, because then I'm going to get flooded with people.
the seeing is a little unstable, but probably around 7/10. So we're going with the green.
So Mike from Asteroid Hunters is asking about cooling. Did you acclimate the scope? Did you cool the camera down, or are you running any type of cooling at the moment?
There's no need to cool because it's still early in the morning. So I think overnight the OTA has cooled. Oh, the seeing has deteriorated. At least we had an earlier capture, decent capture earlier, but it seems like yeah. Normally early in the evening, I would cool my C14. It takes about probably 2 to 3 hours to cool the C14. With this is with passive cooling. With active cooling, you can probably do it in. Wait a sec. What happened? Um, Seeing is not very good right now. It's a good thing we took an image earlier. So yeah, this one it's not necessary. This has been cooled overnight. So it's 5 a.m. here right now. So there's really no need to cool this OTA. So everything you set the limit here. If you want to use AVI or SIR, the filters are basically switched automatically. So I don't have to do uh, manual switching of the filter. So everything is controlled through ASCAM. Oh, seeing is not good.
Yeah, I just noticed this was dropping. So, Chris, while we're waiting for this, how long have you been doing this? I mean, how long did it take you to get to this point?
I started imaging planets in 2003 during the Great Mars Opposition, and basically started imaging Jupiter in 2004. This is a slow process. We learn along the way. We learn from others. When I started, I had some few imagers help me, like um, Eric Nang from Hong Kong, Wei Leong Tan in Singapore. There's this guy, Dominic Derrick in Belgium. And of course, Damien Peach was there to help me out. And along the way, we get advices from Anthony Wesley, Don Parker. A lot of imagers really helped out. And I wouldn't say that, in my case, I'm still learning from people on how to get things done. um, my way of imaging isn't really, I don't really want to get, the best images every night. My goal is to get scientific data. Right now we're supporting the Juno spacecraft. So in, I think, April 10, we're going to have another perijove. So this is actually the region that what we're imaging right now is the region where Juno is going to image in 3 days. What day is today? Uh, Today is oh no, no, next on April 10. That's next week. Next week Saturday. So this is the region that Juno will have a high resolution image later on next week. So this data would be very important for professional astronomers. Those are using Juno. And there's another thing with my workflow. I have a limited amount of time. Unlike now, right now we have a long vacation. In fact, we have an indefinite vacation.
Yeah,
It's one
exactly.
of those days where, uh, uh, after some time, you look forward to work now. you know, it's always you look forward for a weekend, but normally I would, I have limited amount of time that I can do. I have kids, I have work, so I have a limited amount of time that I can capture, or else I'm gonna be stressed out in the office, and my wife might start complaining. And I have limited amount of time in processing the stuff that I have. So I try to have an efficient workflow. So this is what you would need. You have to have a workflow from this preparing your telescope to capture. Imaging right now is actually a challenge. Waking up at very early in the morning is not that easy. That warm bed. It's difficult to get up out of the bed at 3, 4, 4:30 or 5 a.m. just to image Jupiter. But it's fun. It's challenging.
I know we covered this yesterday, but people are asking which camera are you using and why?
I'm using a QHY 290. I'm happy with this telescope. It's actually a cooled version. One thing I like about QHY is their cameras are sealed, and one thing I don't have a problem with QHY compared to other cameras is dust. And for me, dust is one of the biggest problem because I've spent over thousands of dollars and of different methods. In fact, I have an electrostatic gun i- in my cabinet just to I thought that it would help in removing dust, but there's really no way with the current chips that we have, the big chips, to get dust perfectly out. And so far with my experience with the nitrogen sealed cameras which QHY has, it's dust sealed, so I never had problem with dust. And so far, I work with QHY in improving their drivers. So if you notice, everything is flawless. As you move from filter to filter, there's really, or when you do binning, you don't have any crashes. Everything is flawless.
Yeah, I mean, I got to admit, they've come such a long way from the early days, and they've. I mean, this is the thing about QHY and other competitors for the CMOS technology is they've made astronomy affordable for most of the people out there. I mean, when you pick up one of their QHY cameras, I mean, instinctively, you're getting a serious piece of hardware right here, and you'd be
Yeah,
thinking you'd be paying hundreds of thousands of dollars for it, and you don't. They're
that's
all
true.
affordable.
Yeah, that's true. That's true. Well, QHY has a $50,000 camera,
Well,
but
yeah, they
but but
do.
but but in the end, yeah, it's really affordable. And to have a dedicated planetary camera, this is something that QHY and ZWO did, because before we used to get cameras from security cameras, and the problem with these is that we really had to talk to them to modify the way they capture, to make it suit for astronomical purposes, and to have a cooling system. Even though I don't use a cooling system, is something which is very important for me. If you notice the temperature here, it's 29 degrees. If I use the uncooled version of this camera, the temperature would be around 50 close to 60 degrees now.
We can actually see the sun coming up on the on your other camera. It's getting bright really fast.
Yeah, it's gonna get bright. So we have to go to Mars right now. Give me a second. I'll move the telescope to Mars.
Okay, so while he's doing that, I'm just going to remind everybody, if you want to enter our draw for a $50 gift certificate, make sure you subscribe to our YouTube channel and subscribe to our Instagram and send us a direct message. You can enter as many times as you want, I guess, but it only counts as one entry because we only see your name once ultimately. So yeah, just go ahead and do that. It's a $50 gift certificate. We will be announcing the winner probably sometime on Monday or Tuesday, depending on the poor person that is actually dealing with it and how inundated they get. So yeah, feel free to fire off some questions. Mike, in reference to your question, which mount is he using? He's using a AP 900. We did that a little bit earlier, so Oh, whose phone's going bing? So if you're looking at the videos down at the bottom, you can just about see Chris fiddling around with the scope.
Okay. We have
Oh,
that tiny thing over there.
I see something.
Hi, good morning, Mars. Okay, here we have Mars over here. Now, one thing about fire capture, you can actually save settings on different planets. So here we have Jupiter. Now we're going to go to Mars. And I already have the settings for Mars here. What's wrong? Okay.
Oh, seeing's really gone down, hasn't it?
No, Mars is very low right now. It's around
Oh.
30 degrees. So it's very close. You know, it's we're a few minutes from sunrise, so the air is starting to get unstable as it heats up. Let's see the red. Okay, we'll just do a little capture. It doesn't take long to capture for let's see. I need to increase new limit. 40 seconds. Okay. Let's do it 45. So I'm doing a 45-second capture for Mars. It doesn't really look good, but later on with processing, this should, you can see the polar caps on Mars. And I think this is the area around Maris Cimerium. I think more or less. Okay. So you notice Mars has a higher surface brightness, even though how small it is right now. It's about 6 arc seconds right now. And I'm using a faster exposure time compared to Jupiter and even lower gain on red because it's just right now it's a high surface brightness planet. I would say Mars would be the easiest planet to capture. And later on this year, for those of you in the northern hemisphere or for us in the northern hemisphere, Mars will be perfectly placed. It'll be about 22 arc seconds. Hey, is there something wrong with my focus? Things seems to be. Wait a sec. Let me redo the focus. Yeah, it was a little out of focus. Sorry about that. Looks better now.
Yeah.
Seeing is a little better. It was out of focus. Sorry. So I'll just have to delete these two. Looks better now. The tiny Mars.
Which actually is your favorite planet to actually image?
Well, for me, Jupiter is the most dynamic. Saturn is probably the most beautiful, but it takes quite some time to image Saturn. Saturn, actually, you can see Saturn now. If you look at the sky now, you can see the 3 planets lining up: Jupiter, Saturn, and Mars. What is interesting was that last time I imaged Mars, I think 2 weeks ago, Mars was actually close to Jupiter, but right now Mars seems to be moving away from. In fact, Saturn is in between Mars and Jupiter now. So
yeah, I think this summer we're going to have a really good view of all the planets, especially when they're all grouped together.
Yeah.
I mean, the last time it happened was like 3-4 years ago for us.
You know, one thing crazy is this November, Saturn and Mars is going to have a very close conjunction. They would be around 6 arc minutes away from each other. This is going to be a very, very close encounter between these two planets. Very rare, really, to have these two. This is blue. You can see that the blue is featureless, and you can see the polar caps and some hints of clouds. That's it. I mean, that's all you should see with Mars. If you see some albedo features, then there's a, you know, you might, or if your blue image is bright, then there must be some light leak, IR leak on your filter.
So don't substitute with bad filters.
No, okay. There we go. Mm. Mm. You'll notice that the eastern, the left side of Mars is very bright compared to the. I wonder what's going on there.
Answer to George Hall's question, why doesn't he use the auto guiding? We've actually answered that earlier on in the stream. It's basically to do with
Mm.
it's not in its optimal point. Plus, he was setting it up so quickly that he didn't really have time to get all of that stuff working right off the bat.
Yeah, the reason why I don't do auto guiding early in the morning is, first of all, my brain isn't 100%, and right now I don't really have that much time. Early in the morning, the thing that I want to do is image and go back to sleep, and using the hand controller isn't really that bad right now. My mouth is well, polar aligned, so I don't really have to do a lot of adjustments with the planets. Just a few clicks here and there, and setting up the auto guiding. Yeah, takes time. Takes time. So what we're gonna do now, because sunrise is coming up, we're gonna do one last set of after this 3 sets of Mars and IR. Then I'm gonna demo to you how how to set up the filter wheel to make it automated. Okay, let's lower this so you can see my camera. Okay, you can see my camera set up there. Oops, sorry. Last run. So you can see my telescope and camera there. In fact, I just use a Telrad.
I think sometimes the simplest is the easiest method.
Yeah. Oh, by the way, the camera.
Oh, it's disconnected again.
Okay.
Which is it? This one?
The other one. Well, I think that's the one. Yeah, that's the one.
Oh, I think the laptop froze. Is it moving for you?
No, it's not.
Yeah, no, it's stuck for me.
My laptop is okay.
Uh-oh.
Just reboot that.
Okay, let me just reconnect it then. I'm assuming you're using Wi-Fi and all that stuff.
Oh yeah.
It's probably what it is. Just let me know when the laptop comes back up and I'll get you reconnected.
No. My laptop is okay. It's not. My laptop is okay.
Oh, I can't connect to it now. Now, guys, just so you understand, Chris is actually in the Philippines and I'm here in California. So this is it's quite a feat to be connecting two sides of the world together like this.
Yeah. We're gonna do IR. Then we're gonna I'll show you how to set up the filter wheel. It's more than 100%. You're still connected with the team viewer here. I'll reset team viewer.
Not on the other laptop. I'm connected to one of them, but not the other. Yeah, I'm connected to the ThinkPad.
Try going team viewer again. Oh, wait a sec. I'm offline. I wonder why.
Oh, that's probably what it is.
Okay, wait a sec. Okay, I'm online again.
All right.
Okay, this is the last IR. Okay. So we're on the last run here for IR. Okay. Okay. So we're done with imaging this morning. If you want to set up the filter wheel, all you have to go to is here in the settings. First, you set up the motorized filter wheel and basically initialize. And you can get the choices here. This time I'm using the Starlight Express filter wheel. You can see the properties. It has 7 filters. Okay. Then once everything is set up, you go here, filters, and you make sure that you can use RGB sequence. You place R, G, and B. I would recommend that you have a 2-second delay because once the filter changes, there's a slight vibration that happens. And jump to the first filter after the sequence. So you just check these. And one thing when you're using here, fire capture, where was that? File naming settings, capture settings. Use WinJupo's file naming convention. Always use this one. And what else?
Hey, Chris, your battery is at 26%. Somebody's just pointing that out to you.
Oh yeah, it's this laptop, but okay. Oh, okay.
We don't want to lose you halfway through.
Okay, wait a sec. Let me power it up.
Thank you for looking out for us, George. Or sorry, Gregory. Much appreciate that. Now you know we're actually live. Anything can go wrong. So again, if you haven't entered our $50 gift certificate draw, you got to subscribe to our YouTube channel and subscribe to our Instagram account, and then send us a direct message, and then the winner will be announced probably on Monday or Tuesday. So don't delay, get subscribing.
Okay. And do you guys have any questions?
Is a telescope in OAS mode equivalent to equatorial when imaging the planet, since the cameras have a high frame rate with only 30 to 60 seconds exposure?
We actually have. I've tried imaging out as, but I was using a 2.4 meter Richie Chrétien in Thailand. Oh, the seeing is better. Let me do a little capture with Mars while we're talking. We had a field derotator. So you probably need a field derotator. I'm not sure. I think a few people a few years ago they were using Dobsonian on imaging, a track Dobsonian, and they were able to get good images. But I think when you're using derotation, that might be a problem.
Oh, did I miss a question from Greg about another question in regards to OAS? If you don't mind, just type it again, and we'll answer that for you. George is asking, what arc second per pixel are you imaging at?
Right now it's around 0.1314 arc second per pixel. So this is really very high resolution.
Okay, so another question would be are you using a Barlow, and if so, what are you using?
I'm using an Astrophysics Barcon. This is the Barlow I've been using since the beginning. The reason why I use this is it's a variable Barlow, and the quality is actually pretty good. I never had a problem with it. Yeah, it's a 2-inch Barlow. You can actually see my setup right now as the sun rises. Later on, we'll have a close up. After I do this Mars imaging, we'll do a close up with my setup. I think you can see it here right now. Oh, seeing is very good now.
Go figure.
Suddenly. So just imagine Mars is only 6.3 arc seconds right now. So it's tiny. Later on this year, it'll be 22 arc seconds. So it'll be a lot bigger later this year. You'll see that I don't have anything fancy on my telescope. I don't even use go to early in the morning. Since planets are bright, I just use my Telrad.
Do you ever do deep sky imaging?
Well, once in a while I do. Rarely. The problem I have here is that I have horrible light pollution here in my area, so I don't really do a lot of deep sky here. But once in a while, I can image comets. But when I do deep sky, I normally don't use this telescope. I use my astrophysics refractor for deep sky.
Oh, since you just mentioned refractors, is there a difference other than focal length? Is there a big difference with imaging between a refractor and a reflector for doing planets?
It's aperture. A 7-inch refractor would cost 100 times more than a 7-inch Schmidt-Cassegrain. So you cannot imagine owning a 14-inch refractor.
Well, the funny thing is I actually have access to a 230 refractor that we're probably going to use in the summertime to do planetary imaging.
You're better off with a C14.
I know.
Yeah.
But you just like to try that out.
Yeah, or even a C11 would be much better. But refractors are very nice telescopes. But they're good for wide field deep sky, and that's what they're made for. Probably for planetary, it might be less expensive and easier to mount a reflector or a cat. And this it boils down to budget.
Right. I mean, out of all the different type of reflector telescopes, which one really is the best one? I mean, we've got quite a few choices. You have a Mac Newt, a Mac Cass, you have Newtonians, obviously, SCTs, you have RCs, you have the plane wave CDKs. I mean, in your opinion, I know you use the C14, which we can see.
Yeah,
but
I've also used a CDK. They're nice, but they're way out of my league.
Well, have you actually used it for imaging, and do you actually see a noticeable difference?
I was in Thailand. We have a 1 meter CDK there. I do a joint project with Narit in Thailand, and we actually use their CDKs there. Uh, they're actually good, but the thing is, a 1 meter CDK is about $1 million, way out of my budget.
Well, they could always loan one to you, I guess.
Well, that'll be nice. But really, realistically, if I could afford, I'll probably get a 24-inch classical Cassegrain. That'll be nice, but budget-wise, probably on my dreams.
Okay, after the stream ends, we need to talk, okay?
Okay. Okay, we're done with imaging. Any other questions with regards to the camera?
Not yet. I'm sure people are going to keep on sending questions in.
Okay, because I'm gonna shut down fire capture because in a few minutes the sun's gonna rise, and anyway, I'll give you a tour around. I don't have a portable camera, so I'm just gonna show you. So this is my imaging system, the flip mirror and the Crayford focuser here. And this is the cable that goes to the controller. This is the flip mirror. The flip mirror is really a lifesaver, especially early in the morning. It's really frustrating to get the planet into the field of view of the camera uh, if you don't have a this Crayford focuser. In my case, this is an old Crayford focuser. It's a Homeyer Crayford focuser. I think a few companies still sell. I'm not sure. I think Vixen sells one. You can search around, but having a flip mirror really is a lifesaver. Uh, the Crayford, you have to have a heavy duty Crayford focuser because these can be heavy. You have the filter wheel here. This is the Starlight Express and the QHY 290 over here. So for now, my system works very well for the setup.
And it looks like you're on a pier mount. Is that right?
Yeah, it's a portable pier, and you never go wrong with the astrophysics mount. I've been using that for since 2003. It has never failed me. Although I had to change some cables. I have some backups on practically all the cables that I have here, just to make sure that I could image every night or every clear night. But overall, this mount is you can't go wrong with this mount.
So this is actually a question that was sent to us earlier, and since you've actually got your camera up, can you talk about your cooling setup because it seems different? It almost looks custom.
No, this is the ordinary QHY for the telescope.
Yeah, for the telescope.
Oh, I never used that. Actually, when I bought it, I bought my telescope secondhand, and it has a Piltier cooler, but it was a big hassle to use it. So in the end, I just gave up. I never used it. Hopefully, in a few months' time, when this thing is over, I'll probably get a newer Schmid Cassegrain because my problem with the C14 is that the optics isn't really good right now. It has some dew inside. Yeah, I really have to open this up and clean it, but right now I don't have the guts to do that. I'm a bit nervous to open things up, even though I've been to the Celestron factory and seen how they do this. But still, it works for me. Then I'll still keep on using it until I get the new one.
So another question here is, would there be any benefit of using, say, the Edge HD version over a standard version?
I don't see any big difference. Damien Peach uses the Edge version, so the only reason I would prefer the standard probably is to light, more light, because the Edge has a lens on the close to the the back end, and that lens you probably lose about 3 to 5% of the light that comes in. So that's basically probably the only difference. But flexibility wise, I would probably prefer the Edge.
So if they made a 24-inch of the Edge, you'd probably grab that then.
My problem is having a 24-inch Edge is to mount it. I don't think my AP900 could handle it, so I probably need a bigger mount for that. But then again, when I got this mount, I got this for half the price of what it's selling now. So I'm happy. Those were the days.
Oh yeah, totally.
Yeah.
So just out of interest, what other cameras have you used other than the 290?
Well, I started imaging with a 2U cam, the Philips 2U cam. That was ages ago. Then I started using the imaging source, the MK21, and we also there was a time I used the point gray camera. Uh, Basically, then for quite some time, uh, I used some of the Celestron cameras, which was the imaging source cameras, the Skyris cameras, and once they stopped developing cameras and the 290 came up, then this is where I started using QHY 290.
So another question here is, can you use an off-axis guider instead of a flip mirror?
Um, one thing. The thing is, you use the flip mirror to center the object, and off. I wonder if the off-axis guider would do that. I don't think so, because that's why it's called an off-axis guiding. It picks off on the edge. The reason why we're having the flip mirror is because we want to get the planet into the field of view. So it's easier for us to manipulate, to center. Without the flip mirror, it'll probably take you 20 minutes to get the planet into the field of view. So it saves time, and especially right now, I don't have 20 minutes. You want to have everything in seconds. And one thing nice about the flip mirror, earlier when we were imaging in methane band, you noticed that I had to close the flip mirror to take dark frames. That's going to make things very easy for us. And one thing you'll notice in fire capture, I wonder if you noticed this one when we were imaging in fire capture, is that it saves all the settings. So you don't have to go through you don't have to set up everything all over again. Uh, let's see. There's Mars. Hi, Mars. If you notice, let's place this Mars in the center.
Oh, are we going back to your screen? Hold on one
Okay.
second. Hold on
Okay.
1 second. Am I on the right machine?
The other machine.
Oh, it's not this one?
Oh yeah, this one. Okay, we're there. Now, if you look at the
hold on.
okay,
I'm trying to get the thing to do the screen share. Where is it gone? Uh-oh. Hold on.
what happened?
I'm trying to get the screen sharing back. I don't know why I lost it. Oh, it's me.
Just in case, sun's coming up. You can see the sun is almost coming up now. Look, the red thing over there. It'll be sunrise soon. I'm actually on top of a hill, so
There we go.
I'm actually on top of the hill, so you can really see the sea over there. And sunrise is coming up. You can see the sunrise there. Okay, you got now. You'll notice that in fire capture, they actually save the settings. So that's why when I go to methane ban, it goes straight to binning. So when it goes back to IR, it saves all the setting of IR. This is Jupiter, so Mars is currently overexposed, but you can see every setting is saved from the exposure, the integration time, 30 seconds, exposure time, gain. It will save the last settings that you have. So for each planet that we have, this is one thing nice about fire capture because it saves everything. And you'll notice that each filter that I use have different gain settings. So this is 372. This is for Jupiter, and for green it's 389. Of course, this changes as depending on the transparency and seeing. So this is one advantage of fire capture.
So one of the questions is, I lost it there. I'm going to scroll back down to it. The exposure times that you were using, there's no actual magical setting. That they're always based upon what you physically see. Is that correct?
That is correct. It's just like when you ask somebody when you drive a car, what gear should you use? So it depends whether you're on a highway or on a side street. So it all depends on your conditions. Everything is variable. Even here in the Philippines, you don't get 10/10 seeing, perfect transparency every night. Transparency is always different whether you have a haze, smog, or whatever, or everything is perfect. So things are different, settings are different. So you have to live with it. We'll
So
see.
is Saturn up right now? I mean, could we just have a quick look at Saturn?
No, it's already. You can see the sky now. It's blue. You can't see Jupiter even, or Mars for that matter.
Oh, it looks like we. Oh, is this? Are you just playing back the footage, or is this still live?
This is live.
Oh,
Look,
okay.
look. This is blue now. You can see the background. It's already very
Ah,
bright.
yes, it's starting to wash out. That's right.
Yeah, yeah. So yeah, it's basically over now. So basically, we'll process this tomorrow. I'm gonna process this today, but tomorrow we're gonna have a workshop on how to process all these images. So if you have any questions on processing, oh yeah, one thing about you'll notice about QHY cameras compared to other cameras, the gain is all on proper dB. So let's say it's 280, it's 28 dB, and you'll notice that it has extended gain up to 730 dB. So this is one thing nice of the QHY camera. One setting that you have to bear in mind is the USB traffic. Remember, other cameras and QHY, they have different settings for the USB traffic. For high speed capture, I would always recommend for USB traffic you use 3. This is only for QHY cameras. Other cameras, they have different settings, and I cannot really tell because I haven't really used the other cameras, and I'm not familiar with them. So for QHY, if you're using USB traffic, the best is 3.
So somebody's asking, and I know we covered this yesterday, but do you need to refocus between each filter?
Red and green, no problem. Normally, that's why we focus on green. Uh, for blue, it's slightly out of focus. Hey, good morning. The sun's up.
Yeah, we can see it.
I have to start taking down my stuff now. So
Oh, so real quick then, before you take it all down,
mm,
how do you normally store everything? I mean, do you leave that stuff up or do you throw a cover on it?
yeah, I'll show you the cover. There's the cover over there.
And who
So
makes
that's the.
that?
I may have it custom made here locally.
Oh, you had it made custom made. Yeah, so Telegizmo's sells a cover, the
Yes, yes.
Telegizmo 365.
Yeah, I used to use Telegizmo, but I found it cheaper just to buy it here. But actually, Telegizmos, I used to use that, but because of our weather here, it doesn't really last that long. Probably about 4 or 5 years. Then I have to change it. I have to change the cover because of the sun and rain, and yeah, and I store everything here in this box. So the cameras will go in. The only thing I leave out is the telescope and the mount.
All right, then. So Chris is going to start packing some of his stuff up. And what we're going to do is we're just going to play a quick promo video. And we're going to come right back. And then we're just going to open this up to more
Questions?
questions.
Okay.
And we'll go from there. All right. So don't go away. We're just going to take a quick break. So if you need to pee, now's the time.
I'm Jen Winter, and I own Daystar Filters, and we're actually out of Warrensburg, Missouri, flyover country out there. We have lots of square footage, lots of acreage, and big blue sky. I've had a very strong math background, and I was studying mechanical engineering very early on, but I also was heavily into photography, scanning things. I worked in a newspaper, so I was in media with a math background, or math with a media background. The two came together when I met my late husband, Vic, who was an astrophotographer with the Kansas City Star. And I was instantly hooked on astrophotography because it was a marriage of that art and science both in together. And Vic really got me addicted pretty early. He pulled a 16-inch Dobsonian out and put it on Saturn, and the rest was history. That's one of the worst ways to get hooked, of course, Saturn. How many people hooked on Saturn? I always like to refer to a story when I was in school. We had a gentleman who was working in Kansas State University in Manhattan, Kansas, and I was going to school there, and a gentleman discovered there was, a grad student said, "What do you mean we have a planetarium and nobody goes to here?" So he went around to every school, everywhere, brought every student, every person in town went to the planetarium that year. And in my little group, as we were going up to the top floor, we passed a room in this physics building, and here were these guys in their little brown corduroy suits, just all excited because Voyager was going by Saturn, Jupiter, I don't even remember because I was so small. But here they are, they're showing video of a planetary pass and getting data live. They were coming out of their skins, jumping up and down in the chair, and I'm like, well, you know, this is really interesting. And I was fascinated at that moment, but I got dragged away to go to see the planetarium, which frankly, after seeing actual images of the planets, seeing the dots was a little bit less. Well, I think we need to get a little bit more hands-on and a little bit less hands-off. I'm finding that when we do outreach, in our area of the country, there's an awful lot of outreach, but I find that the youth are becoming so addicted to their screens, and there are so many good pictures of astronomical things out there that seeing something on the web is sufficient. They're satisfied by seeing these Hubble images. But when they have the chance to look through that telescope and see Saturn through the eyepiece, there's always a moment where they question, is this actually real? Am I actually seeing this? So that direct connection to the equipment, having a hands-on experience instead of a cyber experience, that makes more of an impact, I see, in getting them moved along further into astronomy. We found that schools have more difficulty getting, with budget issues, they're having difficulties getting people out to field trips for nighttime astronomy. But daytime astronomy, of course, you can go right to the school. We have outreach guys who can, and there are even a lot of outreach support groups where you can participate and even have access to materials to get out and visit the schools. And during the daytime, the teachers are much more likely to have activities and the hands-on opportunities daytime versus nighttime. It helps a lot. The most important thing with the sun is, because the sun is so bright, astronomy is usually about collecting light, and more light is better. But with solar observing, you're buying dark. The sun is already bright enough, it's so bright that it'll blind you. So with solar, we always have to reduce down the amount of light that's going to damage your eyes through infrared and ultraviolet radiation. But also, if you reduce the light from wavelengths that you don't really care to see, then you can start to pick out details that you wouldn't otherwise. And the hydrogen is all about, perhaps you remember in chemistry that you have these little emission lines that in a spectrum you see lights light up in different colors. So we're going to isolate the color of light that hydrogen emits. So then you can, and hydrogen and helium is what the sun is made of. So then you get to see what the sun is really doing instead of it just being a big circle. Hydrogen alpha will be the brightest line, and if we got more complicated, there are energy levels and how much energy it takes to make different wavelengths of light. Hydrogen also gives, the alpha line gives a more interesting view of the sun. So you have, it's more interesting, it shows more contrast, it's brighter, and it represents an energy level that physicists are interested in the science from. A lot of times folks don't quite realize that the sun is a star. It's the most fundamental concept about astronomy and about actually solar physics. Everybody gets excited. There's even, what is this, the new TV show Rick and Morty is all about physics, all about the physics. Well, we happen to have a really cool physics experiment. Einstein's theory of relativity references things like the sun in it. And so solar physics is astronomy, except up close in a way that we can watch it change hour to hour, day to day. We're still today, even Citizen Kate is learning more about. The Citizen Kate was the project where they were looking at the sun during the eclipse. We're still doing real science on the sun every single day to learn more about physics that we didn't know yesterday. So I like solar versus nighttime just for that interactive aha moment where it's not just black and white dots.
Just let me know when.
All right, we are back with Chris. We're just going to give you a quick sneaky peeky of what he's doing right now with some of the processing. We will cover all of this in depth tomorrow. So this is not the actual processing. We're just being impatient. We just want to see some stuff.
Okay, this is the image we got this morning. This is how it looks stacked. Let's see. Doesn't look bad. Not bad. You can see the oval BA and the great red spot and the wake of the great red spot. You can see the difference without wavelets and after wavelets.
That's quite amazing, that is.
Yeah. And I don't know, because it doesn't really look nice on my laptop screen, but it'll look nice on my desktop screen.
Oh, it definitely looks good over here. I tell you that much. I mean,
Yeah.
the amount of detail is astounding.
Yeah. And this isn't even the perfect seeing. This is about probably around 7. Let's check Mars, because Mars is faster to process. Let's see. So what do we have here? So you were asking how we use this. Mhm. Oh, this is gonna be interesting, because I think we'll be able to see some of the volcanoes.
Oh, really?
We'll see.
Ooh. George Hall is asking, how many frames did you capture on average?
Hi, George. Nice to hear from you. Basically, well, it depends on condition. There's really nothing specific. There you go. Well, this is a little over processed. I need to here. Yeah, this is Olympus Mons over here,
Oh, wow.
and this is Elysium. So yeah, you can see some volcanoes.
And so Olympus Mons is actually the largest volcano in the solar system.
Yes, it's the largest, highest volcano in the solar system. And what else do we see here? Not much really, because Jupiter, Mars is still very small. Let's see. I think we'll get more information here.
Now, again, guys, we will be covering the processing part of this tomorrow at 4 p.m. Pacific time.
Yeah. What we're seeing, the white thing is really, this is Olympus Mons, and this is Elysium. Yeah. So we can really see this is Olympus Mons and clouds over Elysium. So not bad. We still have the polar hood, polar caps on Mars. This wasn't a bad image for
No,
this
it
time
looks
of the year.
great.
Yeah. Any other questions?
Well, no, we've got, there's tons coming through now.
Okay.
I know we're going to answer this one tomorrow, Greg. So please come back tomorrow. I know you're probably curious about the wavelets thing, but he will explain all of that tomorrow. Martin is asking, do you need to be careful to not let exposure times get so long that you actually miss a lucky image and seeing goes from good to bad during the same frame? How long
Yes.
does an instance of this of good seeing last?
Really, in my case, I can predict more or less how good seeing will be. Well, it depends on where you are. As I said, use the highest frame rate that you can with your system. If in my case, I'm using close to 100 frames per second, and you're talking about, in this location, the seeing is actually pretty good. Sometimes you get about usually this time of the year is supposed to be 9 to 10 over 10 seeing every night, but we still have winter weather right now. So even this late, well, quotation mark, winter weather, winter winds, we still have the northeast monsoon, which is supposed to end last month, but it's supposed to be summer here right now, the hot season, but it seems to be delayed. So during this time, when seeing is good, you can actually do slower frame rates. Well, it depends on your camera, telescope, focal ratio. There's really no fixed thing. You really have to find your sweet spot.
This is a question that was submitted earlier, or actually from yesterday. Is there any difference in using larger pixels? The general consensus would be big telescope, big pixels, small telescope, small pixels. But is there any massive advantage over using a camera with larger pixels? Because you use the
Hmm.
290, which is only a 2.9 micron.
Well, it depends on really on your seeing and your location and also the telescope type you're using. If you're using a Schmidt-Cassegrain, in fact, I won't mind if I have a larger pixel. But the thing is, my Barlow will have to work some more. I may have to use extension tubes for my system to get the magnification that I need. But really, it depends on your system. Uh, Honestly, I'm not happy with the way that the pixels are going smaller and smaller. I'm happy probably around 3 to 4 microns.
So what would be the
But
ideal micron size for your particular scope? Sorry, my cat just decided to get
uh,
up there.
Uh, it's okay, no problem. It's not really about the micron size, but the sensitivity of the telescope. Oh no, the sensitivity of the chip that I look at because of the basically the QE of the chip more than anything, than more than the pixel size.
So
Because
when you're
the
So when you're referring to QE though, quantum efficiency, what is the actual number that they should be looking for?
It depends, but right now, I would prefer the BSIs, the back illuminated chips like the 290, because they're far more sensitive. Right now, the 290, even I think most cameras right now have almost the same QE. The 178, uh, even the 163, they've in RGB they have more or less the same QE, but in fact, I think even with in IR, the QE of the 163 and the 290 are about the same. The only difference is the pixel size. The pixel size of the 290 is slightly bigger, 2.9 versus 2.4 with the 163. So well, it boils really down to that. I prefer larger pixels for in this case if the QEs are the same. And
Uh,
one thing I'm waiting for right now really is there, there are two types of CMOS: the rolling shutter and what was that? Um,
Global shutter.
the global shutter. I'm waiting for the BSI global shutter. That will be a game changer,
Oh yeah, definitely.
especially when. Mm,
So I think Sony is supposed to be coming out with that in 2021.
yes, I've been waiting for that, and hopefully when that thing comes out, I'll probably upgrade to a newer camera. And one thing I like about that camera is that I think the pixel size are bigger, so they'll be good.
So do we have any more questions on the live chat? I mean, I see a lot of comments, which we muchly
Mm,
appreciate.
mm.
This is my cat. It's a she. So yeah, I have a space cat. And funny enough, if you're looking for a space cat or a red cat from William Optics, we actually have them in stock, believe it or not. So if you haven't already bought one, don't hang around because they're going to be gone real soon. Oh, since I forgot you could look
Yeah,
on your internet, people are
yeah.
asking how to find you on social media and things like that. So here's your chance.
This isn't really social media, but this is my website, astro.christone.net. Uh, this is my Jupiter image. So this is my Jupiter image last year when Jupiter was higher in the sky. So and much bigger. So you can see the details on the. This is what you can do with good seeing, uh, uh, Jupiter closer to us, close to opposition, and you can see all the details there, even inside the Great Red Spot. I think I still have some nice image.
Quick answer to your question, George. Is there a number on that camera? I don't know if they've announced it officially, so I'm not going to say anything about it.
I actually have the number, but until it's it's released, then I'm not supposed to talk about it.
Yeah, I know.
I actually Sony has released some specs of the camera, and one thing nice, it's huge, about I think 1-inch chips.
Yeah, it's that much we can say, but we're not allowed to say too much about it.
Yeah. So you can see the Jupiter here with the. You can even see details inside the Great Red Spot.
Is this probably one of the best images that you've taken so far?
I don't think so. Probably one
you
of
know
the
what?
better
Show us
images.
the best image you've taken so far.
I really don't know. I really can't say which is the best. That thing doesn't really concern me. It's basically how much we can contribute to science more than anything else.
Well, hold it. Let's keep on this picture for a second, because there's something actually quite interesting going on this picture. Is if you look at the red spot, you can see how some of it is actually spilling out almost.
Yeah, this is the flaking event that we had last year. This was in the news last year, where we have these small ovals that went through the halo and basically extracted some red material out of the Great Red Spot. People thought that the Great Red Spot was shrinking because of this, but after this event, there was really, the Great Red Spot really survived unscathed with this. So you can see, this is one night. You can see this one is very good seeing, and this one is not so good seeing. So even in one night, you can see changes in the seeing conditions. This is the IR and the methane band. And you can see a lot of interesting things going on in the methane band. They're brightening. So a lot of interesting things going on.
Real quick, what do those numbers at the bottom mean? I mean, you've got 18, 12, obviously that's universal time, CH4 is methane bands. What's the other numbers there for?
These are the central meridian of Jupiter. There's 1, 2, and 3. And you can get these in WinJupos. And you'll notice earlier, you notice the equatorial band is dim. This is last year. This year, the equatorial band is very bright. Remember when we took the image earlier of the methane band? Where was that? Here. If you look at the methane band image, look, this band is very bright. So there's things are different every year with Jupiter. Nothing is always the same.
So what's probably the best or the most interesting feature that you have captured since you've been doing this? I mean, you've said you've been doing this for well over 10, 15 years.
Yeah. Probably the most exciting was the impact on Jupiter on what's that? June 3, 2010.
Do you have anything? Did you image anything at that time?
Yeah, I imaged the impact.
You got tons.
Yeah. Look at this image. Look at here. Wait a sec. I think I'll have the full. This is the full video. This is the actual raw video I had of the June 3 impact. You see here, over here?
Oh, yeah, there it is. Now, you knew this was going to happen, or was this by chance?
No, this was by chance. Anthony Wesley was the first one to see it. When I was taking this, I I wasn't really observing well. It wasn't until he said that, oh, there was an impact, that I went through my video and saw this one over here. Look.
Oh,
So what happened was a 20-meter asteroid or comet struck Jupiter during that time.
oh, this would have been great if you had it in the methane band by chance.
This was okay because in methane band you have slow exposure time. This one they were able to basically make a graph on how bright it was and basically estimate on how big the impact was from this data and Anthony's data. And one thing coincidentally, Anthony we were imaging at the same time. And one thing interesting, he was imaging in red and I was imaging in blue.
Oh, right. So somebody's asking, do you have any footage of good seeing, like a 9 out of 10 or a 10 out of 10?
Let's see if I have it here. Oh, by the way, George Hall was one of the other impact detect. He also discovered an impact on Jupiter. So hey, hi George.
Oh yeah, George is here.
I know this guy. I've met him a couple of times, and we communicate with each other. Let's see if this is a good one. This is an old image. No, this is a color image.
Oh, sorry. Go back. Can we see that real quick? Because this gives a really good example of mono versus color.
Yeah, this is a color, and I was using the next image 5. You can see here's a sample of a color, and it's not very bright, but you can see the details of the color image.
So do you actually think there's a big difference between shooting monochrome versus color? I mean, for a color one-shot camera, this is really good.
Yeah, but you should bear in mind that Jupiter was overhead during that time.
Oh, that's true.
Yeah, right now I don't think you can do that. Let's see if I have some data. Good seeing. It's on my desktop where I have all the good data. Let's see. No, I don't have it here.
So do you exclusively shoot your stuff in the Philippines, or do you actually have like a remote observatory set up? Do you have access to other things?
No, I do everything here in Cebu.
So it just goes to show everybody at home that you can do this kind of astronomy at home. You don't have to go out and buy telescope time or any of that crazy stuff. If you've got the equipment, you can do it at home
Well,
to a certain degree.
there's actually this is a plugin for a friend of mine. Um, Up there in Chile, Yuri Viletsky has a telescope there. I forgot the name, and you can actually rent time if you want to image planets. My friend Damien Peach does that, especially right now when the planets are low in the sky in the southern hemisphere. Some people actually do that now. They go um, basically image remote. But in my case, since I live in the equator or close to the equator, so whether it's south or north doesn't really matter to me.
Awesome. So
Yeah.
we've got about 5 more minutes left before we finish this with Chris, because I'm sure he is probably dying to just jump back into bed now.
No, I'm already awake. Oh, you guys want to see this?
Well, of course, we'll see everything you got.
Oh, what's this? Oh, wait. No.
Oh, so you've got stuff with Neptune and Uranus.
No, this is not mine. This is Hubble images.
Oh, okay.
Yeah, this is a Hubble image taken a few years ago. Actually, I also do some Hubble processing for my team. I work with some professional astronomers, and we do Hubble images. And normally, if you're dealing with Hubble images, you have to go through this FITS liberator thing, and basically convert the images to TIFF from FITS. So it's quite interesting, and I'll show you some of the images I did. Yeah, it's on my where was that? So this is an image which I think you're familiar with this image of Hubble of Jupiter using the Hubble Space Telescope. I was the one who processed this image for them, and you can see the press release here. So this image, I was the one who processed for them. This is the official website, and you can see from the credits over here, see go over here.
Woo! There he is.
Yeah, so it's fun to work with professionals, and yeah, from here.
Have you actually had a go at any of the new images that they pulled down recently? Because I've seen some like cracking shots come from NASA.
Yeah, I was the one. I processed those images. Yeah, Saturn and Jupiter images. I don't have it here in this laptop. I have it in another computer. Oh, you want to see?
Yeah,
This
no,
is
we
a
want to
video
see
I
it.
made from. No, this is a video I made from the Hubble images. It's actually hidden here. You can see.
That is pretty
So this,
crazy.
yeah, it took me about 3 days to make this video. Just processing different images to get this video.
So that's probably going to be a good transition for ending this because we're
Yeah.
talking about processing.
We'll have
So
processing tomorrow.
exactly, tomorrow we are going to be processing the data that Chris acquired today that you just watched. If you guys got any questions, feel free to send them over to me now. I will double check the live stream chat just to make sure that I didn't miss anything, and we will try and answer as many questions as possible. Chris, thank you very much once again. I think we could probably do this for hours, but we have to cut this one because I'm sure everybody's going to want to go for breakfast, lunch, and dinner at some point, and I think your breakfast might be coming up soon.
Yes.
So once again, Chris, thank you very much for doing this, and we will see everybody tomorrow at 4 p.m. Pacific time. So do not miss this. Don't forget, we also have Tim Russ from Star Trek Voyager who will be joining us at around about 1 o'clock, and then at about 2 o'clock we have Richard Wright, and after that will be Chris.
Okay.
All right then, guys.
See you guys.
Thank you very much. We'll see you tomorrow.
My name's Chris Heisinger. I'm the owner of Takahashi America, which is the distributor for Takahashi telescopes in North and South America.
My name is Ryuichi Hashimoto, the Takahashi Japan. I'm in charge of the managing director in the international sales. In Takahashi opinion, is very important to the USA market. And I'm exported to the US. And, we're proud of good quality and high-end mania for the telescope and the reflector. And so this in the NIF, we are releasing to the new product is a Starbase 80 for beginners. My company important to the whole expanding to the astronomy market. So before we have the mainly to the mania for the telescope, but for the we have the beginners telescopes have the so expanding, so the beginner for the growing up the telescope market. For Takahashi is very proud of this issue.
So Takahashi was actually introduced to the American market 40 plus years ago by a company called Swift, which imported Takahashi-made telescopes under their name. The company that owns Takahashi America had a strong relationship with Swift, and when Swift decided that they no longer wanted to sell telescopes, Takahashi America started to, or the predecessor to Takahashi America started to import the Takahashi scopes directly into the United States. I believe that was sometime in the 70s. Takahashi's been producing astronomical telescopes since the early 1960s. I think that Takahashi has a long history of excellence in manufacture, and the Japanese in general have a very strong culture of quality control and precise engineering. And just over the decades, they have refined the telescope designs to be best in class among the competitors. The telescopes themselves are finely engineered and refined, and Takahashi has a commitment to a premium product, so that they are meant for the serious amateur astronomer and some professional astronomers.
And we have the casting part of in factory, very unique production company. So almost the telescope mount is a machining part, but we have proud of casting part in a factory. And in the future, we are proud of continue to the product to the casting. And all telescope is handmade in Japan. And craftsmanship have our factory staff, and I'm direct selling to overseas and direct selling to domestic, and so one by one the telescope is so very proud is a good quality control to the telescope.
Takahashi is continually innovating and looking toward the future, and there are several designs in process to supersede existing telescopes and to introduce new models into the market. An example of that is the FOA 60, which was released last year. It's a fluoride doublet, but it's a wide airspace doublet that shares some features in common with the TOA series. So it's capable of really high strels and extreme magnification, and is ideal for planetary work. So there's constant innovation ongoing, and I think that in the future, the future is you'll see continued innovation in the future.
And recently, the CCD camera manufacturer is more to the very improvement camera and very low prices. So almost the customer using to the CCD camera. So Takahashi thinking in the future telescope is best attached the digital camera CCD is proceeding to the new equipment. And so of course now current FSQ16ED is a very adjustment to the camera, but in every time improvement in new equipment, new telescope. If you customer have the idea, please you send to for us your idea. I'm so thinking about the improvement telescope and mount.
The ability to image with telescopes and to make that more accessible to the general public, both from a price perspective and a technologically understanding perspective, is important, because the imaging in the past has been the domain of the very technically literate, And the more that we as an industry can make that more plug and play, so that people with a smartphone can easily take images with a telescope, an inexpensive telescope, the more attraction it will have for people who grew up in a smartphone generation.
So in this Japanese astronomy market, the same problem in the youngest generation. The youngest generation not spend on the equipment, all of them, not especially the telescope astronomy. So we're thinking about so expanding to the astronomy market for the domestic and overseas, and we usually using to the telescope and the equipment, and usually using to the smartphone, the controlling to the system, and more so in very in the astronomy and space universe is very interesting. Some issues. So information. I have to information to all of us. It's a responsibility, I think.
Growing up, I was always interested in science technology. It's every kid's dream, it seems, or at least it was, to be an astronaut one day, and I shared that dream. I ended up studying engineering and was an engineer for a while, and astronomy is a very technical hobby, so it tends to attract people who like technical things, and engineers usually fit that bill. So I was an amateur astronomy, not nearly as serious as some of my current customers, but over the course of my career, I tend to stay technically focused, and at some point I decided that I wanted to do more than just be an amateur astronomer, but actually own a business that serves the astronomy community, and that's how I got where I am today. I think my piece of advice, and this is what I tell people when they come if they come into our shop and ask about what they want to do and how they should get started, particularly when it comes to astrophotography, is start simple. Start with a short focal length refractor, start with a simple camera setup. Don't worry about guiding, don't worry about any sort of the complications that can come with astrophotography, because I think you get a solid foundation of the basics, and then you can build upon that. If you go in too deep and get too technical too fast, you might get in over your head and decide that this hobby is just too much.
In Japan, there are star party in some of the definition. Takahashi Japan is an exhibition to the using telescope, so the observing star is the coming to people. So we thinking so the ordinary people getting chance to the observing and getting chance to take a picture for the star is so many people interested in the universe and space. Please, you ordinary people coming to the interesting astronomy equipment, and so join to us, please.
I was born in Japan and started astronomy almost 4 years ago. That time, of course, no computer. Just I wanted to use a film camera, and I like camera before, but I want to attach camera to something else. And first optics was microscope, so taking something with a microscope. Then next step is I use telescope with camera. And meanwhile also I take picture and developing film myself and printing myself. That's almost 4 years ago. That's my first step into astronomy as a hobby. My basic motto is I'm selling, as a company, I'm carrying and selling product. What I tested, I used myself and accepted. I'm carrying those products. Otherwise, I cannot suggest or recommend customer. So basically, the product I'm carrying as a HUTEC, I know everything from merit or demerit, advantage or disadvantage. I know everything. So that's why I can answer all of questions from customer. I don't say only good thing about that. Each product has various point, good point or not good point. So I honestly, I can tell customer. So if particular customer is not looking for right part, I say so. So this is not your product, and also I don't carry that. So please check around other place. So always I direct talk with customer honestly, and what this customer looking for. So if it's not the right part, I tell clearly tell to this customer. Optical design is all done in Japan. However, I deeply involved from developing stage and mainly mechanical part. So how it looks like and how mechanical part working good, and it's my always question is this finish is good looking for American or European customer or not. That's my biggest point to start for developing. From beginning, always my optical designer thinking about finished product for imaging purpose. So that's why designer didn't think about only objective lens. At the same time, always thinking about best match with field flattener or reducer. So that extra 4-element lens. So it's not extra parts. Just from beginning, designer is design same time for perfect match. So this is why a dedicated system. So this additional 4-element is dedicated design for 107 fluoride. Both used to have various telescopes, including ED element. However, ED telescope is getting more popular in the market. So now we're more focusing on fluoride optics. It's very unique, only coming from Japan, and polished, made by Canon Optron. So that's a kind of key sales point for both. And 107 is this moment is top of the line, and small brother is 90 fluoride, and there's a same optical configuration, and one fluoride, one ED, and total 6-element advanced spectral design. Those are kind of high-end, and this one is one smallest 55 fluoride. So, and also we have 71 fluoride and 90 fluoride. In my personal opinion, fluoride is clearly different from any ED in my experience. And I feel fluoride shows us very transparent and high color contrast. So that's, for me, is obvious difference. Yeah. So it's no comparison with even any kind of ED, high-end ED. In my opinion, it's different. Personally, I like wide field and nebulosity, and it depends on target. Basically, I like big sensor, so almost automatically its target should be larger. But sometimes I like small galaxies. That time I use dedicated CCD camera because that maybe create more high resolution image. I think at least I can tell, because this is a hobby. Hobby means it's culture. So because of culture and always different, American people, Japanese people, and European people has each slightly unique culture. And Japanese people generally likes smaller, compact product. But meanwhile, American people probably opposite side. So simply saying, always I'm telling to Japanese friends, the culture-wise culture is Japanese mind, American mind is all opposite side. Meanwhile, European people is middle, and other Asian people is close to Japanese. So maybe that's using my marketing strategies, because the telescope Japanese people is not always is favorite for America. So I have to always think about the particular product is favorite for particular market or not. That's my marketing strategy. If customer is happy for our product, that's my goal. Because I'm one of a hobby person, I know people's expecting the product, and if it is satisfied, I'm happy too. So me, myself, same thing. So that's why I'm always thinking about each person, the product buying from us it makes happy to customer or not. That's my always concern. And if some feedback is very good feedback, I'm very glad it's feedback too.
Part of the challenge that the amateur astronomy community is facing is to bring in more people into the hobby. So we've been actively trying to contact different people, science communicators, people with influence are also interested in astronomy, to help them help us popularize the hobby. I think it's very, very important for all of us to do that, because as a hobby, we want to make sure that it's growing. And one way to do it is reach out to younger people, make sure that the next generation, the younger people, are actually getting into the hobby.
Basically, I look at it now and I think of astronomy as more of a really artistic. You look at all the beautiful pictures that they do, and I think that's going to bring more people in. It's like getting the big buck for the hunters. You want to get the most beautiful picture that you can get, and it's kind of a competition, really, something that can be achieved, and you don't have to have physical strength. You don't have to have all these different things, but you can go in and just be able to have that creative spark and eye, and go out there and work with it.
I guess what I do is I have a small group of friends near my home, and if I have a night where I decide to take out the telescope, I'll invite them along. It's not really their hobby, but it's nice to branch that out. But I would like to do some outreach to some high schools or elementary and get the kids interested early, so that it's not something you're starting when you're 20s or 30s. It's something you start early on, and you just get that for your whole life.
Already we can see that the impact of social media has popularized astronomy a great deal amongst people who just have no real direct interest in astronomy, but they get excited about these things. Like this eclipse that just occurred had one of the largest turnouts that have ever occurred for a solar eclipse. And I think it's 100% due to social media and the news coverage that it gets. So I think that is making it more important. In other words, you can reach people much easier now than you ever could before.
I think the general public is more into, the now results, So a lot of people like to share things. I find that people like sharing, they want to see results, they want to make things easy. So I see a expansion into just easy imaging and sharing.
There's a lot of people now doing science, not just astrophotography anymore. There's a lot of people doing science. There's a lot of citizen science, and there's schools that are doing science. The easier we make the telescopes, the more science that the schools can start doing. We get colleges doing science, and maybe even down to high schools doing some science projects with NFS grants and such. So because the capabilities of the telescopes today are so much more, I think the way to get the young people involved is to get them using them in schools.
On the scientific point of view, astronomy is trying to answer very fundamental questions, and most of them have to do with cosmology, meaning where does the universe come from? And there are still many questions. Most of them are unanswered. The other search, I think, in astronomy is searching for other planets, other intelligent civilizations, or even sign of life, simply sign of life on other planets. I think that's the second quest. The first, I believe, the first should be trying to find out, answering the question, the big question of cosmology today.
I think there's a renewed interest in astronomy. You know, it really peaked for our generation, or the generation slightly before us, with the moon landing and the Apollo program. And then we had the space shuttle, but with the cessation of flying the space shuttle, people predicted that there would be less interest in astronomy. But you know, as Cassini and some of the other probes have demonstrated, a lot of interest is generated because we're getting looks at our solar system with the technology that has been put into these probes that we were never able to get before. And I know that the generation, my children's generation, has a lot of interest in these types of things, and I think that interest will continue. And those are the future astronomers and future amateur astronomers that are coming out of that.
I think what you're going to see, and what you're already seeing, is that amateur astronomy is making significant strides in the professional realm. You've got amateur astronomers finding comets and asteroids and near-Earth objects, and I think that's just going to continue to happen. I see a network of astronomers, maybe a network of satellite imagers. You know, if you can turn households into a satellite spot, and suddenly you've got a satellite telescope that's the size of a hemisphere, you know, just because amateur astronomers are working together. I see that happening. I see the entire community coming together and doing more.
In terms of making astronomy something that it can reach a much broader audience, we want to see more development of those accessibility options via the internet and ease of use, to try to make it a simple process. Using your iPhone is a pretty easy thing to do, and it'd be great if we can get to where people can access these high-end telescopes and take these terrific images and also do research. You think about the science projects we did when we were young, in some respects pretty primitive, what kids can do today.
You know, one of the most successful programs that I've seen for engaging younger students and younger kids in astronomy is the Sonoma County Astronomical Society has a program where they have students, little kids, like write essays, and then they take the best essays on astronomy and they give them telescopes. And these kids, I've been surprised, it's mostly girls. These kids, they get these telescopes, they bring them to star parties, and they become little experts, little amateur astronomy experts, and they give public talks and presentations. And this is one of the most successful places. I'm a member of about 5 different astronomy clubs, and this is a great way to bring in a younger generation and help them maintain it, because we've seen over years now these kids come in and they stay in there. And this is a kind of program I think we need to scale it. We need to use it as an example and do it elsewhere. Just sort of one small example of one thing we can do.
We live in a fast age, right, where our movies and our music, our media, fast edits, instant gratification, loud and in-your-face kind of stuff is required to hold people's attention today for a half a second, which is sad. And so the subtle and the esoteric stuff suffers. I think it's very difficult to get a lot of younger people into this as a hobby. It seems like there's more younger folks, even women, who manage to get into the professional sciences, astronomy, cosmology, whatever it is, but in the amateur way, getting them to a telescope, getting them to a dark sky, inspiring that wonder in them it's difficult, I think.
Giving someone the opportunity to not only see it for themselves, but do it for themselves, and say, here, have a look. If, for example, if they have the privilege of looking through a telescope and seeing the rings of Saturn, give someone that opportunity to do that and see it for themselves with their own eye, it has an incredibly powerful impact. And what I'll find, and for those who, like I say, there are many outlets where you have an opportunity, city star parties, outreach events. Once you see it for yourself, it's like a catalyst that the rest starts to take care of itself. The interest will be there.
One of the things that concerns me greatly is the fact that so many people are moving away from science and from facts. The fact of the matter is math, history, science, and facts matter. And so to advocate that and to advocate education, I mean, I believe that college education should be absolutely free. We should be investing in the brain trust of this country. And so to me, our job is to advocate science. Our job is to inspire people to really embrace what is right.
The stars are for everybody. And I would like, if I could do that, if I could spread the interest out amongst everybody, that would be the biggest contribution I can make.